Okay, so I'll be doing number 9. The problem gives you that the trait for male pattern baldness is recessive and is represented by the lowercase b allele. And then the non-balding pattern trait is the dominant allele, which is represented by the capital B. So the data they provide you with is, out of 1,000 men, 360 had male pattern baldness, which would be homozygous recessive in this case. The other 480 who did not and were heterozygous, meaning they did not have the non-balding. And then 160 had a full head of hair, which would be our homozygous dominant. So the first part of the problem asks you for the phenotype ratios, which is just the ratio between baldness between men to hair, which is very easy. We can calculate by the data, which would be 360 who were bald, which were the homozygous recessive, to 640 who had hair, including heterozygous and homozygous dominant. So the second part of the problem asks you to find the allele frequencies, which is the capital B and the lowercase b. And this is relatively easier to find because they already give you Q squared, or homozygous recessive, which would be 360 divided by 1,000. So the amount of people with baldness divided by the total, which would be 0.36. You have to remember that this is Q squared. So at the end, you would square it and get your Q. Now, we would use one of the formulas provided by the Hardy-Weinberg principle, which would be P plus Q equals 1. We already have Q, so we would just subtract it by 1 and find P, and then we can find that P equals 0.4. So this would be our lowercase b, and this would be our capital B. So now to find the genotype frequencies, we would use the second equation provided to us, which is P squared plus 2PQ plus Q squared equals 1. So the P squared represents the homozygous dominant, the 2PQ is the heterozygous dominant, and the Q squared is homozygous recessive. So all you would have to do is plug in the numbers. And we will find out that homozygous dominant is 0.16. Heterozygous dominant is 0.48. And last, homozygous recessive is 0.36, which we calculated in the beginning. So that's it.